Alright, so first thing that we're going to do is classify polynomials based on the highest power of x, which is the degree. And then we're also going to compare and contrast zeros to a function's factors and to write a polynomial as a product of factors. Alright, so I think we've seen something like this before. We're just defining a polynomial function. And again, this might look just, a little confusing, but we're basically just looking at I can't. All right, we're looking at something like f of x is equal to, a little number in front, like say 5x to some exponent, say to the 6th, plus 4x to the 5th minus whatever, 3x squared plus 2x minus 1. So that is a polynomial, an example of a polynomial function. Okay, next, let's take a look at polynomial functions classifying by degree. Okay, so if you look at a function, don't automatically look for the front. It's the highest degree. So if you have a polynomial, now this is not a function because it doesn't say f of x, but it's just a polynomial. You look at the degree of 3 that is in front, and it is a degree of 3. And we call that a cubic polynomial. Okay, and then the next one, you look at the highest degree here is a 2. So the degree is a 2, and you should know that that is a quadratic. And then this one, don't look in the front. It's the highest degree, which is right here, and that's a degree of 4, and we call that a quartic. And this one here is a degree of 1. It's not written there, but it is a 1 sitting there, and it's of course linear. And a degree of 5 would happen to be a quintic, and there are other ones, but these are the ones that you should know. And so when we talk about cubics or quadratics, you should know what we're talking about, and I'll use the same language. Okay, so we might need to also talk about some other things, and if we talk about the leading term and the leading coefficient, you have to know what we're talking about. So the leading term is just the terms are basically the things separated by addition and subtraction in a polynomial. So the leading term is the term that contains the highest degree. So since it's a degree of 3, that the leading term then is 5x cubed. Which means the leading coefficient, the coefficient being the number in front, is a 5. Okay, the next one is degree of 2. So the leading term is negative x squared, and the leading coefficient is the number in front of the x squared, and that's a minus 1. And this one, do not say that the leading term is 6. It's not the one in the front, it's the one that contains the highest degreed exponent, so that's 3x to the 4th, and then the leading coefficient is a positive 3, and then this one is linear, so the leading term is 4x, with the leading coefficient being a 4. Okay, here are some examples of some graphs of polynomials, and if you notice these, they are all continuous, meaning there are no breaks anywhere. There are no vertical asymptotes. There are no holes. There are no horizontal asymptotes, slant asymptotes, no asymptotes at all. They are smooth and continuous. So smooth means you don't draw these graphs all choppy with lines. Okay, they are nice and smooth curves, meaning smooth, they're very curvy, there's no straight parts of them. We talked about that in class the other day. Okay, no, they can really just look just about like anything. And, again, in contrast to all the rational functions that we've had, there are no asymptotes and there are no holes. And also the domain of every polynomial is all real. Now, to look at the range, you're looking at the graph. So this one here, I would say that the range is like from 0 to infinity. This one, it's kind of small, what I'm looking at, so maybe negative infinity to -1. And the range here, I can't quite make that one out, but whatever this low value is, maybe a 3 to infinity. So we'll take a look at these at some point in some detail soon. Okay, a couple other things we need to know is that there are, just like lines where you have slope-intercept form, you have standard form, you have point-slope form, that there are forms of quadratic equations as well. Now, we already took a look at vertex form. I like to call this vertex form, but technically it is called standard form. General form looks like this. General form looks more just like a polynomial, where here you might have like 2 times the quantity, x plus 4 squared, minus 7. And that would need to be FOILed out to get the general form. And then there's what's called intercept form or factored form, meaning that you have it all factored out, and every term, every factor is completely factored, and I shouldn't have to say completely factored, but the polynomial is factored after doing some work to it.